Hey there, it's Reza and I'm thrilled to have you here on my channel. In this tutorial, by popular demand, I'll be diving into the world of Unreal Reader plugin, covering everything you need to know. First up, I'll guide you through the process of installing Nuke Server to establish a seamless connection between Unreal Editor and Nuke. Next, we will handpick our maps and sequences from Unreal, loading our render passes and exploring the myriad properties offered by this remarkable plugin inside Foundry Nuke. But that's not all. We're taking it a step further with a compelling case study where I'll demonstrate how to integrate new elements inside Nuke in our scene to elevate your final product to new heights. I've packed a ton of valuable insights into this single tutorial, so get ready to gear up and let's get started. Alright, let's start by downloading the plugin from the Foundry website. I'm using Nuke 15 in this example. You click on Windows, Unreal Engine, read terms and conditions, don't forget that, and I agree. Once you download, I'm just going to go and unzip the file. And of course, within that folder, there's a Foundry folder which we need to copy. So I'm going to go copy, and then I'm going to go into program files in my C drive, Epic Games, Unreal Engine, and then plugins, and just paste the folder right in there. The hard part is done. Let's fire up Unreal Engine. We need to load the plugin. You can go either to File or Settings, Plugin, and type in Nuke. Nuke Server shows up, tick that, and of course we need to restart the engine. And once that's done, I'm going to close the plugin window. I'm going to go into Windows, and there we have our Nuke Server. Let's start with our Unreal Engine in the next chapter and work from there. Not long ago, I did a tutorial on how to export object IDs, motion vector, and depth paths using a render queue from Unreal Engine into Nuke. And I went through all of these properties and attributes, and I explained why and how we can tweak them for ideal result inside Nuke. Now, what we're going to explain is how to load our level into Nuke instead. So instead of going in there using EXR, bake everything into textures and bring it into Nuke, we're actually going to load this scene with our cameras into Nuke, and we are going to generate passes and tweak our scene inside Foundry Nuke. And all of these are possible using the Reader plugin. So that is extremely useful, very exciting. So we are not going to use these guys, but please do check out that video, because over there I do explain the difference between full material actor folder and layout, and it's kind of necessary to know what does what, since we are going to use CryptoMatte inside Foundry Nuke. Now, we don't need to use a movie render queue. I'm going to close it. We're going to go straight into Window, into Nuke Server, and we are going to activate this server right here. All you need to be mindful of is the port number, which by default mine is 9000. It really doesn't matter. Whatever number you have here should match the server number or port number inside Foundry Nuke. So we remember 9000 and we go start the server. And if you do that too often, you can always go start server automatically. With that, as soon as you run Nuke Server, it starts connecting. So I'm going to go start server and it's running. One last tip before we switch to Nuke, we go to edit, we go to project settings, and in here, we're just going to type in post processing. Under post processing, you need to make sure that your custom depth stencil pass is enabled, custom depth temporal is enabled, and very important, enable alpha channel support in post processing set to linear color space only. That allows you to get alpha channels that match your stencil passes. We are going to talk about stencil passes, but you must enable these settings in Unreal to be able to use that inside Foundry Nuke. Here I am inside Nuke X. Remember, you need to use Nuke X, not just a typical Nuke. Otherwise, you can load the node, but it's going to be grayed out. I am going to make sure that I'm in my node graph, and I'm going to press Tab, and I'm going to bring in Unreal Reader. It's erroring out at the moment, but we are going to connect because I need to connect to a server. On the right hand side, we've got the host name and the port number that you need to be mindful of. Same port number in Unreal Engine. Make sure you have that. Connect to server. It's going to think and it should bring the scene. Now, there are two problems. First things first, I should be able to see the scene. I'm not seeing it. And a second issue, the aspect ratio and output resolution is different. So let's address those two really quickly. 2350 or 1000, because of course mine is the camera output resolution is cinematic. So I'm just going to go to Nuke. S in the right hand side, the property window, I'm going to bring project setting and I'm going to add a new one, 2350 to 1000, and I'm going to call that airport. It's necessary to name it, of course. I'm going to press OK. The aspect ratio is fixed, but why I don't see anything? I'm going to double click, and there is a project tab that you always need to check. If you deal with a simple scene with just one camera, one location, one set of maps, then you will see the picture immediately. But if you deal with a rather complex scene with multiple cameras, multiple angles, different folders for the textures, different maps, then you need to set those up. I've got project, the path for the project is correct. I've got map, the map that I have, if I really quickly go in there and bring in my content drawer, I can get rid of that. You can see I'm using terminal single. And I am going to pick terminal single. And you can see I'm getting the result. The sequence has been detected properly. The sequencer that I'm using is called sequence sign. And the idea is to sort of look at this sign and make some changes. So that bit you need to be careful about. Output, there's really not much here. Scene unit is set to Nuke. Render mode is set to full image, so you can see the output. There is another mode, and that is stencil layer, and that allows you to see your layers inside Nuke. Let's say you have cryptomat layer and you would like to visualize that. You go into stencil layer so you can preview your passes. We will get to that and we will use that. Now, the image format is already set to the right one. You can always go and edit that or create a new one, but since we are using the right one in the project settings, it will read that automatically. Also, we have a write section, and that might bring some questions that, well, we have, if I press W, the good old write. Why do we need to write this from here? This is actually called pre-rendering, and that allows you to optimize the workflow and speed it up. So I highly recommend you to use that, and we will be using that actually throughout this tutorial. Now let's talk about Render tab, and that allows you to select all the passes that you can think of from this scene, extract it, and actually bring it into our Unreal Reader node. Now, it is important not to overdo this, so only select the passes that you actually need. In our case study, we would like to replace this frame with another sign. So simply because this has been obscured by this tent right here, we definitely need to bring some sort of a masking pass to be able to create the holdout. And of course, CryptoMatte does that for us beautifully. So probably the most important one in this list would be CryptoMatte. Of course, since we're dealing with replacing or tweaking the existing scene, we always want to bring world position, and I would like to bring world depth as well, simply because I believe I can just add to the scene using that. And since we are using, and I am going to just add path tracer to the mix as well in case we need it for our case study. Now, it doesn't update it automatically. You need to go update channel list. If I look at my layers, we have just the main components, RGB and alpha. And if I go update, it will go through this. And then if I go into here, we have our crypto passes, we have our path tracer, world depth, world position at our disposal. Alternatively, for CryptoMatte, if I go up here, you can switch to stencil layer and then see the preview, layer preview, in order to see the CryptoMatte, but we are going to just work with that for now. Now it's time to pre-render our scene and optimize the workflow. Why not? I'm just going to go in there. I'm going to define the path. Now, defining the path is not going to cut it. I'm just going to use with pre-render underscore terminal underscore, and I'm going to specify the paddings 1, 2, 3. I've got only 100 and something frames, so it's not going to be too long, and you need to specify the extension. I'm going to enter. The file type is already set to extension. Data type 16-bit. We want high bit depth and compression set to none. Now we have create read node. Make sure that's enabled. Once we render everything, then create read node is going to create the read node for us. I'm going to go right. We get an error, which is normal because behind the scene, Unreal Engine is actually rendering everything. If I go to Unreal Engine, you can see that it's actually rendering these frames. We are going to wait for these renders to be finished. The animation is well underway. It's just a subtle zoom in. And once that's done, we should be able to see the thumbnail. Now the render is done. All I need to do is just to read from the file. I'm going to plug that in here. If it still doesn't show, double click on the read node and reload. And you should be able to see the image. Now we don't need to work with the plugin anymore. We can just work away from here. If I go to my layer, you can see I've got these passes. Path tracer is also included for us, which is great. World depth, world position, and all other layers that you may want to bring. Now, there are more into this, so you can sort of go through the CryptoMatte and think about, all right, what type of CryptoMatte we want. Remember, we talked about this in our object IDs in our Unreal Engine playlist, so definitely check that out if you're not familiar with this. I'm going to switch to material on this one. There is no translucent object, but if there is, you can always take that. If you bring any color correction or color management file, OCIO, in Unreal Engine, you can definitely bring that here and switch. Just to show you where you can find it, if you go into Nuke Server and bring that in, there is a open color configuration where you can actually nominate OCIO config, so Nuke actually knows what is going on. And this is a relatively new section. So beforehand, we had to actually use OCIO converter and then use the disable tone curve to tackle this issue. Back in Nuke 13, Unreal Engine 5, I'm using 5.3 and I'm using Nuke 15, so that's really not an issue anymore. You can enable and disable motion blur if you want. And we are going to go into cameras and talk about cameras. It's just playing a massive role in our case study. And of course, in this node, you can just write a label and take it from there. In variables tab, you can write console variables, which we're not going to use. And that should really do the trick when it comes to covering the node itself. Now let's go to the next chapter where we actually start this as a case study to be able to tweak this scene. Okay, I will be using the same shot for this particular case study. I've gone ahead and tweaked a few bits and pieces, like putting a few assets in the background, changed the direction of the light, changed the color of this tent, moved some objects around, added bloom, nothing too special. And Nuke Server is running, so let's switch to Nuke. Here I am inside Foundry Nuke, and I've already gone ahead, not to waste any time. I took care of the pre-render via here. The path is established, read file is on, it's all ready to go. And another thing I did inside the render tab, I enabled CryptoMatte, I enabled path tracer, and I enabled world depth, world normal, and world position. For what we're going to do, it is necessary to have all three enabled. Now, what exactly is the objective of this case study? We would like to go ahead and change this sign. So we replace this sign by this sign right here. Now, there are few challenges, namely this tent is obscuring this sign right here, so we need to find a way to take care of the holdout, and we also need to color correct that sign using all the nodes that are available to us inside Foundry Nuke. Now, what we have, if I just switch the viewer to the read node, let's go over the layers that we exported. We have CryptoMatte render pass, we have the good old path tracer, and the reason I included path tracer because I really don't like the look of this lit mode. If I go into RGBA, you can see it's really dull, it doesn't have any indirect illumination, and I spent a good amount of time going over all right, let's put some background here, let's make the background a bit dramatic, let's introduce a little bit of bloom and lens flare, so it would be a shame not to have the path tracer. And of course we have world depth, world normal, and world position. We are going to move this guy over here, and I press dot to create a dot node, another dot to move this down, and we are going to shuffle some of the information that we have in our read node. The beauty of using shuffle node is if you ever want to pass along the information to another compositor, everything is cleaner to read, and of course that's a great way of extracting information as a layer within a read node and pass it on to shuffle so you can use it in conjunction with other nodes. So I'm just gonna connect all three in here, and it is very important to name them properly. All right, this is going to be my RGBA, so I'm not going to change anything, and in the label I'm going to call that RGBA, so we know what we're dealing with, and the label is here, easy enough to read. I tend not to rename the node itself, but to add a label instead. The second shuffle node is going to be our world position. Input layer, world position. So we are actually bringing that layer into this shuffle node, and this shuffle node is going to act as a container. We can pass on the information to whatever node we're going to create afterwards. All right, I'm going to call that world P. And the second one is going to be our world normal. And the good thing about world normal is you have control over the orientation of your points. And everything is clear, ready to go. Feel free to recolor, rename, but I'm not too really picky about that. Now we have this information. How will we be able to use that? Well, world position allows you to actually extract information and put that into point clouds. And with the help of RGBA, you can color that, and world normal is going to help you to fix the orientation if there is any issues. The correct node to use that is position 2 points. So I am going to create that, and you will see very soon that actually world position does expect world position in our shuffle node. So I can go and connect the RGBA to world position. World position goes in here, and you can see the node is smart enough to be able to identify this position right here. And then we have normal, and if I connect that, you can actually see that it says norm, identifying this shuffle node as a container that passes on normal. This is fantastic. I'm going to switch to RGBA, and I am going to plug the viewer in, and instantly we are getting a 3D representation of our scene. This might come as a blobby object in your scene, and if that's the case, because of the point size, I'm going to reduce this point size to something like 0.01, and it's much smaller. If your computer can handle it, I would also increase the point detail. Definitely not necessary. All right, so far so good. How are we able to use this information then? Well, if I go through the scene, you can see I have actually access to the 3D position of this object. So all I need to do is just to place a 3D card node and position it carefully and properly, and we can make that switch. This is really good. So let's actually get to work. I'm going to go in here, and this is a time where we are going to sort of dive into more 3D nodes, and I try to do my best to explain some of these nodes as we move forward. If you already have experience in Nuke, or perhaps watched my Nuke Essentials playlist on YouTube, there's a good chance that you may know all of these nodes. We're going to start with a card. So I'm just going to go and press tab and type in card geometry and load that in. And if I press F, hovering my mouse on the viewer and press F, you can see the card in the 3D position. Now, one way of doing it is to, of course, go in here and try to sort of position that object manually. But before I get ahead of myself, I'm just going to add to this card, and then I have all the time in the world to position it properly. So every time you bring a 3D node and the indication is round corners, 2D nodes are sharp and angular. But in order to feed in multiple 3D nodes into a scene, it's always a good practice to actually bring a scene node. I'm going to plug that in, and that allows you to, if you have more cards, if you want to incorporate or implement more objects into this scene, that allows you to do that. Now, every time you bring a 3D node and plug it to a scene, you need to find a way to render it. And we are going to do that using a scanline renderer. In Nuke 15, we have scanline renderer version 2, which is in beta mode, and we have the classic one. We are going to use the classic one. And that expects your scene, SCN, that is your scene. You can potentially define the resolution by putting it or plugging it into any constant, and that defines the resolution of this scene. But remember, if I press S in the properties editor, we already define the resolution, so that is definitely not needed. And I'm in general not in a big favor of plugging anything into background, BG for background. But also, this expects a camera, and we do not have the camera in the scene. So how are we going to sort of view it through the lens, which is the tricky part? Well, that's where the power of this Unreal Reader node comes to play, because there is a section that we did not cover in the first half of the tutorial, and that is the camera. You can actually extract the camera from Unreal with animation and bring it into Nuke, and you get the exact same camera angle, aspect ratio, everything will be similar. So with the link output ticked, I'm going to go ahead and create the camera. There we have our camera, and it comes with the expression saying that it's been linked. I'm going to move it in here, and this scanline render expects the camera. You plug the camera in. 2 points. If this line is getting under your skin, you can always go into node and you can hide the input. So if I click away, you're not going to see that green line, only you see it when you select it. The second point is, preferably when you use this method, you want more or less to have everything at the center. But if and only if that is the issue and there is no way for you to fix that, you can use this camera node to somehow find a solution for it. I can duplicate in here, and I can go and create transform geo node, and this expects an axis. An axis is like a locator in Maya, if you are familiar with that. Is just a gizmo that allows you to connect two elements, and the camera actually can follow the axis, and the axis can follow your transform geo, and all you need to do is just to bring that in and reorient your scene. So this transform geo comes with translate, rotate, scale, and even skew, which we probably don't want to use, but this will force axis to move, and axis forces the camera to move. In that case, you're repositioning your scene, but axis will bring along the camera with it. So it's not going to reposition the scene and the camera will be left alone, and then you have to bring and readjust the camera. This is only if you have the scene on the side. There's no way that you deal with it. That's how you use it. I'm going to perhaps delete these guys because we're not going to use any of these. Just as the side information for you. We have the camera, we have the card. Let's actually make that connection using this read node, a simple merge node, and make that connection. Now, before I do that, I really would like to bring my also path tracer pass into play. So that would be a good time to just drop in another shuffle node and extract our path tracer, plug that in. I'm gonna go and fetch my path tracer, and if I look into my path tracer, you can see I'm getting the correct result. Of course, I am going to label it since we are dealing with too many shuffle nodes. I want to know exactly which one is which. And then I can just drop in a merge node. B always goes to the base, and our base is our read node. This is very, very important. And A goes into our scanline render. So you can see now I am getting the information for the path tracer, but I'm also have the option of using this card to be able to sort of move that around however I want, reposition it and rescale it and put it into place. This card node expects an image, so let's drop in our image. I am going to just drag and drop our image in here. And I'm looking at the blue here, and I'm looking at the color here. This is really bright. Now, there are many ways of toning down the brightness, but quick and easy way is to use multiply math node. So I'm just going to drop in multiply math, bring that in, and I don't know, just maybe bring down the value to half, and you can see these two are going to match. Now it's time, I guess, to comfortably go in there and reposition my card using translate, rotate, scale, uniform scale. And if you want to push this out and in, you can use the Z. Since we are using all the necessary information inside Nuke, Nuke can comfortably move this along the Z axis and bring it forward towards the camera or far away from the camera. Alternatively, you can look at the position to point and interactively reposition your card. All right, I thought I would just use the position to point. Since we have the information, why don't we use it? All right, the issue is right now, of course, the tent should be in front of the sign, and that's really not the case at this stage, and that's why we have our crypto mat pass. So let's bring that to use. I'm going to give myself a little bit of room, move it away, and let's bring in our crypto mat. There are many ways of using this crypto mat. One way is to use a copy node as a holdout, which I explained in my how to use object IDs video in my Unreal Engine playlist. And because of that, I'm going to use the second method. So there's an opportunity to learn something new in this tutorial. So to see what's going on, of course, you need to connect that to your read node and view it. And in here, of course, I explained this again in that video, but let's go through that. We can use the picker to add. I'm going to hold Control, click to add, Control Shift click to add multiple objects, and to remove, picker remove, Control and deselect. And because I used material as my crypto mat inside Unreal Reader, then each object with different materials will get a different ID, which is very, very convenient. So I'm going to hold down Control, select this guy, and now this is in my alpha. How cool is that? Basically, all I need to do is just to use merge mask in here, and in mask, I'm just going to invert. That's all you need to do. And if I press 1, this is in place. This is really cool. I believe that my card possibly needs to have a much better position. So I'm just going to view and see if I can ever so slightly reposition my card. Double click on the card to bring out the transformation gizmos, and just going to align it ever so slightly. Maybe push that back a little bit. Yeah, that should do the trick. That's much better. Yeah. So far so good. But what I would like to do at this point is we used pretty much all of the passes. We used normal, we used position, and we used path tracer. The one that we didn't use is world depth. So let's bring that to use in case if you would like to add a little bit of drama into your scene. Again, to extract, we are going to use the good old shuffle, and we are going to connect that to our read node. I'm going to move these two guys a little bit up, and the flow has to be top to bottom. With this guy, what we are going to pick is world depth. I'm going to go into node, world depth, so we know what pass I'm dealing with. I'm just going to drop in a grade node, because if I look into this world depth, it's just really hard to translate. We really don't know what we're dealing with. And this grade node is going to help us to sort of tone down these values through the gain to be able to sort of translate that. And what we usually do, we're dealing with very, very small value. And you can see that I can just going further with that. But I honestly believe that what we have doesn't require too much atmospheric. 0.005 should be good. I'm going to sort of flatten the values, pressing C on the keyboard to bring a color correct node, and I'm going to just kill the saturation here. View it, and you can see we have the good old depth. This is a good time for you guys to color your haze or fog for sort of more dramatic effect using another color correct, and feel free to label those as well. For this one, I actually am going to increase the saturation ever so slightly, and I'm going to tone down the gamma just a little bit. And with that, I'm going to introduce a little bit of color, and it's totally up to you if you want to sort of add a little bit of orange or add a little bit of blue to the scene, and that gets added basically to your scene. All right, we have the package for our world depth ready to go. Let's connect that. Drop in the merge node using M on the keyboard. B goes to the base, remember, always to the base, and A goes to our depth pass. I'm holding down Control to branch this out. It's going to be a lot cleaner if you branch this out. And right now, if I look at it, it's just way overblown. One thing I can do, if you feel like, all right, you've done some work in the background and it would be a shame not to see it, you can always go to highlight. In this particular case, sometimes it's shadows and sometimes it's midtones, but for me it's the highlights that is just too harsh, too bright. I can just lower down the gain ever so slightly to just gain some of the information that I had. Now from this point onward, you can go ahead and use all the tricks in the books to intensify. In here, if I go, I can use actually screen as my operation. There's nothing wrong with that, and take it from there. Once you're happy with everything and you feel like, all right, your work is ready to go, you can just drop in a write node and write out your script. There you have it. A quick introduction on how to use some of these passes in a case study. If you ever want to create point clouds for further tweaks or introduce some elements, you don't just need to replace an object. You may want to bring an image with alpha and put it in the background. I could actually use some fire in there, some elements that you may want to add into the scene. With the help of this position pass, you should be able to get that one done. I will put this script on my Patreon page in case if you would like to download it and test it and play around with it so it's easier to use. All right, that should wrap up this tutorial. I hope you found this useful and use these techniques that you've learned in this tutorial in your projects. Definitely follow me on Instagram, Reddit, and X. Have a great rest of your day. Until the next tutorial, see you guys later.